Hello. Open up my chat. Please be signed into chat. A few too many things open on my laptop. It's not doing what it's supposed to. Yeah. Please put your name in chat if you haven't already done so. Oops. Okay, I don't think I wrote down what slide we ended on last time. We were graphing trig functions. Had we gotten to sine and we got to sine and cosine.
I believe that's as far as we got, Professor, in regards to graphing sine and cosine.
So, and did we do, let me see, what's that example 9? All right, let me see here. Let me pull this up. Oh, come on. So did we deal with this one?
No.
Uh, oh. So we did cosine as well. We do this one.
I think we had just finished example 7.
We hadn't finished it, or we were on the process of finishing it.
We had finished it. That was it.
Okay. Yeah. Okay. Everybody put their name in chat, because if you put it in there before I signed in, I'm not seeing it, but that doesn't mean it won't be there. Okay. So, well, let me look at the slide before. Slide before dealt with this function. All right, let me make sure. Yeah, that's one we had done before. Okay. And so we're going to be dealing with y equals a -4 cosine of pi x minus 2 using key points. Our key points to start with are 0, 1 for cosine is 0, 1, pi halves 0, pi -1, 3 halves pi -1, 0, and 2 pi, we're back to 0. Back to 1. Okay. So those are the key points we're looking at. So first thing we look at is what I look at is what's happening to the x. All right. So again, we want to look at what a is. We want to find out what from a we find the amplitude, and then we find out what omega is. And from omega, we can find out what the period is. For cosine and sine, the period will be 2 pi divided by omega. And then from here, we can find the 4 key points, 4 s values for the key points if they change. Okay. So what's alpha? What is a? In this function, what is the a value?
-4.
It's -4. So what's alpha?
4.
Yes, it's just the absolute value. And what's omega?
I want to say pi.
It is. It's pi. Omega is what x is being multiplied by. X is what, omega is what x is being multiplied by. And so now our period becomes 2 pi divided by pi. So I need to recreate this without these numbers here. Because now my x scale will be in pure radians. It won't be in my x in terms of pi. Right. I didn't think of that when I created this. And so, so that means I go from 0 to 2, halfway between is 1, and so then we have 1/2 here, and we have 3 halves here. So these are my x. My x values just changed. It's the 0 stays 0, so 0, 1. The 1/2 became just 1/2 pi. Just became 1/2. 1/2 0, and then pi became 1. 1 negative 1, and 3 pi over 2 became 3 halves. 0, and the 2 pi became 2. So that is 2, 1. The next thing that happens is we're multiplying. All right, so that gives us our y values for these x values. So now we're going to multiply each y value by a -4. So instead of 0 going to 1, now 0 goes to a -4. Instead of going to 1/2, instead of 1/2 going to 0, well, 1/2 does go to 0 because -4 times 0 is still 0. And then multiplying 1/2, -1/4 times 1, we get a +4. So now 1 negative 1 is now at 1/4. And then 3 halves 0 stays at 3 halves 0. And 2, 1 now jumps down to 2, -4. Let me see. And then at 3 halves 0. Let me see. No. The background is gone. Okay. So that's what I'm going to have to deal with. So now we have and it goes from 0 to 2. So here's 1, here's 1/2. Three halves. Right. So now we've done this part of it. now we have to do the -2. So that means we're going to subtract. What's going on there? It's not letting me write there. That's weird. So now, we take 2 from it. So now this goes 0, -6, -4 minus 2, and then 0 minus 2 gives me a -2, and then 4 minus 2 is 2, and then 3 instead of 0, and the 2 now goes to -6. So 1, 2. So 2 is the highest value we get to, and -6 oops. I'm bunching them up a little bit there. -6 is the smallest, is the lowest. So we start out at -6, and then we come up to -2, and then we come up to +2, and then we come back down to -2, and back down to -6. And so this is this period of this function. And then we continue it on. We'll go out a couple more points out this way and a couple of more points down this way and graph appropriately. Okay. So the textbook, they identify alpha, they identify A and omega, and determine what the amplitude is and what the period is from those two values. And then they're looking at the negative sign cosine, the -4 cosine theta pi will begin its cycle at 0 and end at 2. And so they divide the interval the same way I did, only they use a little bit more math involved. So each interval is one half. So 0 plus a half plus a half plus a half until you get the 5x values, because our key x values change to these numbers. Okay. And so, and what they did was they didn't do it step by step like I did here, coming down here, where here we changed our x values, and then here we changed the y values by multiplying by the -4. They kind of skipped this middle step here. I did a little bit, because they weren't necessarily showing you how they got those y values there. Okay, so this is the graph of that, but that's not the graph we were looking for. We're looking for subtracting 2 from each y value. Wait, did they show it? Oh yeah, here it is. So here's that one, and then they extended it out, but then they subtracted 2 from each of the y values. So this went down to 2, this 4 went down to 2, and this 4 went down to 2, and this -4 went down to -6, and this -4 went down to -6. And then, yeah, and then the zeros are no longer at 0, now they're at -2. Because we moved our x-axis. That's what happens when you do a vertical shift. You're changing where your x-axis is. All right, the domain again is all real numbers, but now the range, the lowest y value is -6, the highest y value is 2. So this is the set builder notation for the domain, the range, and here is the interval for the range. Please notice the brackets because -6 and 2 are included in the y values. They're not just boundary points, they're actually part of the data set. All right, so on this one, we're going to say we want to be able to write an equation for what we have here. Well, if you notice that it goes through one side, it looks like a sine function. So we look at the period here. Well, the period appears to be 4. Well, 4 is 2 pi over omega, or 4 omega equals 2 pi, or omega equals 2 pi over 4, or pi over 2. So omega is pi over 2. So right away I can change this to say sine of pi over 2x. Now I look at my amplitude, my high value and my low value. My highest value, you take your highest value and you subtract your lowest value, and you divide by that by 2. So you get 4 divided by 2, which is 2. So the amplitude is 2. So now we want to determine, is it going to be a +2 or -2 for A? So I can determine what I multiply the sign by. Well, at this point, it should be at 1, but it went up to 2, so A is going to be a positive. So it's +2 sine pi halves x. All right, it has the characteristics of a sine function, which is what I'd stated. We looked at the period. Oh, well, they're saying the maximum value happens at 1 and happens when x is 1. So the equation, well, the equation could be viewed as a sine function with a equal to 2, because 2 times 1 is 2. And the period is 4. And then they they find the a first, which is somewhat easy to do. So that out of the way. And then they're trying to find omega. And they found it the same way I did. You set this pi over 2 pi over omega equals to 4, and then solve for omega. And we get omega is half a pi. And then you just plug the numbers in appropriately to get this equation or this expression. Any questions there? Okie doke. All right, this one also looks like a sine function. But the first maximum value is at -3. Well, no, the first max or min is instead of going the traditional sine function, which is like that, it's going the other way. So it's going like this. So that means I'm multiplying my A. My A is going to be less than 0. It's going to be negative. And because it comes down here to -3, that means A is going to be a -3, and my amplitude is +3. All right. So right away, I know I can write this as a -3 sine of x. Now to find what I'm at, let me put it this way, it's omega x. So now I need to find omega. So for that, we look at the period, and the period in this case is 8. So that means 8 equals 2 pi divided by omega. So now we have 8 omega equals 2 pi, and dividing by 8, we get omega is 2 pi divided by 8, or pi over 4. So omega is pi over 4, and that's what we multiply the x by. So this is going to be the equation, y equals 3, -3 sine of pi force x. And that's what they did. The amplitude was 3. The period was 8. So that's what we have there. All right. And since the graph passes through the origin but is decreasing rather than increasing, then you're going to be multiplying by a negative number. And so that's where they came up with that equation. Now, here's section 6.5. Oh, let me see. So it looks like we're going to be able to get through chapter 6 for the first exam, like I anticipated. So next, whatever we cover up a full section, we may not, if we're not able to finish section 6.6, that won't be on the test. I know we'll be able to finish section 6.5, but we may not be able to finish section 6.6. So the exam will be all of chapter 6 except for section 6.6. It just depends upon how far we get next Thursday, because the review will be on the Tuesday after that, with the exam being on 2 weeks from today. Okay. So we're gonna look at sine, and we're gonna look at tangent, cotangent, secant, and cosecant. The same way we've been looking at sine and cosine. Now, tangent and cotangent have a different period than sine and cosine, where cosecant and secant have the same period. They have a period of 2 pi, but tangent and cotangent have a period of pi. And you'll see that more clearly when we look at the graphs. Here they graph some of the function values between negative pi over 3 to pi over 3. Please realize that this graph shows a limited domain. Okay, so they're only going from here, going from here to here. Okay, they're not showing the whole period, which is from here. No, from here to here, from negative 1/2 to pi, negative pi halves to pi halves, that's 1 pi. And so that's the period there. But they're only showing a portion of that. Okay. All right. Now, the graph of tangent, because tangent of pi over 2 is undefined. It does not exist. Okay, and so we have vertical asymptotes at the odd multiples of pi over 2. We have vertical asymptotes. If you remember from college algebra, a vertical asymptote is defined by the function as the x value approaches that, as x approaches that x value, the function goes to infinity or negative infinity on either side of that x value. And that's what happened. That's what's happening here. Here it's on either side of pi over 2. On coming at it from the left hand side, so it's approaching it from the negative side, it's going towards positive infinity. So I kind of wrote these in the wrong direction, of course. So it's going up over here, and on the other side of that vertical asymptote, the x values, as x approaches it from the positive side, the y values are going down forever. So that's the definition of an asymptote. So x equals pi over 4 is a vertical asymptote. I mean, pi over 2 is a vertical asymptote. And all the multiples, the odd multiples, you wind up with vertical asymptotes. Because the even multiples of pi over 2 are pi are the integer multiples of pi. And at the multiple integers of pi, you get 0 for tangent. So at pi, 2 pi, 3 pi, and 0 pi, and negative pi, and negative 2 pi, they're all going to be at 0. And where at the odd multiples of pi over 2, you get a vertical asymptote. And it goes through like that. So, and it just keeps repeating over and over again forever. So you see the periodic nature of tangent this way. Wave after wave after wave. Okay. The domain here is all real numbers except for odd multiples of 2. So how would we write that in set builder notation? It'd be all x such that x does not equal pi halves k. K is an odd integer. Okay, so that's one way. This here is saying that x can't be an odd multiple of pi over 2. There's multiple ways of writing it or saying it, but okay. And all real numbers is the domain. I mean the range, because it goes down to negative infinity, which includes all the negative numbers down there, and it goes up to positive infinity, which is all the positive all numbers over there, and includes 0. Okay. The tangent function is an odd function. It is symmetric with respect to the origin. So this point here has a mirror image down here. If x, y is on the graph, then the negative of x and the negative paired with the negative of y is also. So if 3, 3 is on there, then negative 3 is on there. If pi force 1 is on there, then negative pi force -1 is on there, which it is. Yeah, pi force, it's at 1, and at negative pi force, it's at -1. So my graphs here aren't totally accurate. Anything I draw is accurate. Anyway. The tangent function is periodic with period of pi, which I already discussed, and we can see that quite easily on the graph here, is that it just repeats every period, and the period is pi apart, is pi. The x-intercepts are at the integer multiples of pi. -2 times pi, -1 times pi, 0 times pi, 1 times pi, 2 times pi. So all the integer numbers being multiplied by pi. And the y-intercept is at 0. 0, 0 is where it crosses the y-axis. So that point does double duty. It's one of the many x-intercepts, and it is the only y-intercept. If you have a y-intercept, if you recall, you only have one. And then the vertical asymptotes occur where the domain is not. So the vertical asymptotes at the odd multiples of pi over 2. All right. Now the graph of the cotangent, and they're going to do the same thing here. Well, they didn't show you that part. Cotangent has a period of pi. From 0 to pi is the primary period. Okay. Because if you remember, cosine is a reciprocal of, cotangent is a reciprocal of tangent. So wherever tangent was 0, then cosine doesn't exist because you're dividing by 0, which is undefined. So where we have vertical asymptotes for the cotangent, that's the x-intercepts for the tangent. And where you have the x-intercepts for the cotangent, that's where you have the vertical asymptotes for tangent. Because 1/0 is undefined, so that means it forms the, so like right here. Okay. And because it is a reciprocal, yeah, you're changing your x's and y's. Changing them. Tangent is cotangent is it has a lot of the same properties. It's an odd function, so it's going to be symmetric with respect to the origin. So this point down here at negative pi over 4, -1 is reflected there. This point is reflected up there. This point way down here is reflected way up here. This point is reflected over to here. And where this one is going to be reflected to over to here. So that's what happens there with those. All right. Next slide. Now we're going to look at 3/2 of tangent of x plus, why won't it right there? 1/2. Okay. I'm sorry. I have to scope this out. I think I have anyway, I think I have a crack. That's awfully upsetting. Right. Tangent of x plus 1/2. So x is being multiplied by anything. So that means my period isn't going to change. So my period stays from negative pi over 2 to pi over 2. So it's going to stay between here and here for my fundamental period, my primary cycle. Okay. And then the points to look at in here are going to be negative pi over 4, which takes us to a -1 for tangent. And 0 gives us 0. And pi over 4 gives us a +1. So that's what I'm looking at. I'm looking at these points here and the fact that it goes like this. Always put arrows on the end. Okay. So the next thing, we're going to multiply. So these are the y values here. So we get these y values. My x values aren't going to change at all in this particular problem, but I'm going to multiply each y value by the 3/2. So this be negative 4 negative pi4, and then 3/2 times -1 is a -3/2. So this point got moved down to here. Whoops. I need to follow what I have here. So this is the 1, and this is 1. So it's, yeah. So this went down to here to 3/2, and this went up to -3/2, and this one went up to +3/2. So now it's like this. And this is at 0, 0 stays at 0, 0, because 3/2 times 0 is still 0. And 3/2 times the 1 is 3/2. So that's what I did here. And now we're going to add 1/2. We're going to add 1/2 to each y value. So if it happens after the function, after the trig function, then we're changing the y values. So I'm adding a half to a negative 3/2. So that's going to become negative pi over 4 ends up going to -1 because I added a half to it. So it comes back up to here. And I'm going to add a half to 0. So this is 0, 1/2. So this point got moved up to here. And this one, pi over 4, 3/2. I add a half to 3/2, which gives me 2. So this point got moved up to here. So now it's going to be between those two. Oops. There we go. Yeah, this is kind of messy. And for this particular one, yeah, and then it continues over here. At this, it's going to be at 1, and then here it's going to be at 1/2. Oh, sorry, it's supposed to go through there. And then here it's going to be at 2, and so and then going down here, so you want to extend the graph a period below and a period above. So that's going to be there, and this will be down here, and this will be at 2, right? Up here. So you have this one. Questions here? Okay. So they did it using the transformations and multiplied. Since omega was 1, it's not going to change any of our x values. And then we multiply the y values by 3/2, which is what I had done. So this went up. So these values at 1 went up to 1/2. These values at -1 went down to -1.5. And then we add 1/2 to each of those y values to get these, which is, I did it here. I did the transformations here. I didn't necessarily have to graph them. So if you show me the transformations this way, and then you graph the final result, I'm fine with it. So you start with the key points and looks at what happens with the key points and then graph it appropriately. All right, the domain. The domain didn't change from the original tangent function, so it's the same domain as tangent. The set of all x such that x isn't equal to pi halves k, where k is an odd integer. And the range is still all real numbers. If the range or domain is all real numbers, especially with trig functions, it's not going to change, no matter what your transformation is. Sometimes it will, but usually not. Now we're going to be talking about cotangent. All right, cotangent again has a period of pi, but it goes from 0 to pi. So the asymptotes are at the even multiple, I mean at the multiples of pi. So I'm going to draw those in. Oh, I don't know. I'm not going to draw them in yet. Because omega, I have omega now. Since I have an omega that's other than 1, that means my period is going to change. All right, so my period in this case for cosine and for tangent and cotangent is pi over omega, not 2 pi over omega. So we need to determine what omega is. We need to determine what A is so we can state what the amplitude is. Well, A is easy. That's what the cotangent's being multiplied by, and that's 3. And so the amplitude is 3. We're not adding anything here, so there's no B value to worry about. That means it's not going to be moved up or down. We have an omega, and that omega is what x is being multiplied by, so that's going to be a 2. So the period is pi halves. So now my vertical asymptotes are at the multiples or the odd multiples. Is it the odd multiples? No, it's the multiples of pi over 2. Which is pi over 2, pi, 3 pi over 2, 2 pi, and then it keeps going in the positive direction that way. And it goes in the negative direction the same way. Yeah. Now, I have 3 key points for cotangent and tangent. But for cotangent, the 3 values are going to be pi over 4, pi over 2, and pi over 4, it's -1. And at pi over 2, it's at 0. And at 3 pi over 4, it's at +1. Wait a second. I got those reversed. It goes from +1 to -1. Okay. Because it comes down. So now I'm going to multiply each of my x values by 1 over omega, which is 1/2. So I multiply 1/4 by 1/2. So now that's pi over 8, 1. And I'm going to multiply pi over 2 by 1/2. So that's going to be pi over 4, 0. And I'm going to multiply 3 pi over 4 by 2. So that's going to give me 3 pi over 8 by 1/2. And that gives me 3 pi over 8, -1. Okay. So I've taken care of the x values, so they'll fit my new period. And now I'm going to change the y values by multiplying by a. A is 3. So 3 times 1 gives me 8, gives me pi over 8, 3. So instead of at 1/8 pi, I don't go to 1, I go up to 3. And at pi over 4, I'm going to stay at 0 because 3 times 0 is still 0. And then at 3 pi over 8, I'm going to multiply -1 by 3, which gives me a -3. So that's going to be down here. And so there I have the primary cycle. And then I copy it at here. It's going to be up here, and then here it's going to be here, and then here it's going to be down here. Here it's there, and then here it's there, and then here it's there. And I continue over here. At the middle of each interval, it's going to be at 0. And then at the 1/8 intervals, it's either going to be at +3 or -3, depending upon which side of the interval it's on. Okay. Any questions here? I've been doing a lot of talking and not asking for questions. So you do 1 or 2 intervals above and below of the initial interval. And I went 2 below and 1 above. Actually, you could, yeah. So I went 2 above and 2 below. So what they do, they go ahead and show the transformations on the graph where I showed them through these key points. Right. So the first thing they did was they multiplied they multiplied these y values by 3 first. So they did the vertical stretch first, where I did the horizontal compression first. Well, did they? Yeah. They do the horizontal compression second, where I did it first. And so they stretched those points out away from the x-axis. And then the next one, they're gonna compress it by multiplying by a factor of 1/2. So now everything, you can't see me do this. Everything got squeezed in towards the y-axis. So when you have a horizontal compression, everything gets pushed towards the y-axis. And if you have a vertical compression, everything gets squashed towards the x-axis, either pushed up or pushed down. And if you have a stretch, everything's being pulled away from the x-axis, which is what we had in this particular problem. So it was pulled away from the x-axis and pushed towards the y-axis. Okay, and where the y-intercepts, I mean, where the vertical asymptotes are, which are the multiples of pi over 2, that's where x can't be. So we say it's going to be, the domain is all real numbers x, such that x is not a multiple of pi over 2. An integer multiple of pi over 2. And then the range is a set of all real numbers. And there's more than one way to write that. You can say the range is a set of all real numbers, or you can say the range is in the interval from -infinity to infinity, or it's a set of all y such that y is a real number. Or you could say that, yeah, that's it. Y is a real number. All right, this is a graph of cosecant. If you remember, cosecant is the reciprocal of sine. Right? When sine is 0, right? When sine of 0 equals 0, so that means the cosecant of 0 is undefined, because that's 1 over 0, which is undefined. Okay. Questions there? So we have vertical asymptotes where sine equals 0, which is the multiples of pi. So if the multiples of pi, right, equal x can't be integer multiples of pi, we have vertical asymptotes. So that means, and then because sine happens between 1 and -1 inclusive, and the reciprocal of -1 is -1. The reciprocal of 1 is 1. But once you move off of 1, then you get, because sine is between those two numbers, their reciprocals will be outside of those two numbers. because then you have a fraction less than 1, and the reciprocal of a fraction less than 1 is a fraction greater than 1. So all of these numbers in here in this interval all end up going above or below 1 and -1. So it cuts out this middle here, and it's just everything from -1 and below, and everything from +1 and above. And that's what they're saying here. Absolute value of y is greater than or equal to 1, because 1 is in the range, because the sign of -pi/2 and the sign of 3pi/2 are -1, and so the reciprocal of -1 is 1. And here the sign of these values is 1, and the reciprocal of 1 is 1. So we include 1 and -1 in that. The secant has the same relationship with cosine that cosecant has with sine, so it's going to be the same. So the graph is going to look exactly the same, except it's been shifted pi/2. These two graphs, the only difference between these two graphs is if I shift this graph pi/2 units to the right, I get this graph. Any questions there? All right. So y equals and the what do you call it? The period of cosecant and secant are the same as the periods for sine and cosine. It's 2 pi. So our period is defined by 2 pi over omega. In this case, omega is 1. So our period in this case is still going to be 2 pi. So we have 2 times cosecant, oops. Cosecant of x minus 1. And it's going to bug me. Shit. I think my warranty has already gone out on this thing. So for me to replace that, I'd have to buy a whole new one. And I don't want to do that. So it's still going to go from here to here. All right. And at pi/2, so for cosecant and secant, I look at where it's 1. I don't worry about the other values. I look at where it's 1 and where sine is 0. So cosecant is 1 at pi/2. Cosecant is -1 at 3 pi/2. Sine is 0 at pi, so I have a vertical asymptote here. Sine is 0 at 2 pi, so I have a vertical asymptote here. And it's 0 at -1 at 0 as well, so I have a vertical asymptote here. So wherever sine is 0, we have vertical asymptote for cosecant. And in that interval, if cosecant is 1, then that means that's the lowest point. So it's going to go like this in here. And over here, it's the largest point. So it's going to go like this over here. And then since A, we look at A, omega was 1, so it didn't change our period. And so A is 2, and so that means the amplitude also is 2. So that means I'm going to multiply each of my y values by 2. So this -1 this +1 times 2 is up to here. And this times 2 is down to here. -1 becomes -2. Okay. And I think at pi over 4. Yeah. At pi over 4, the sine is 1/2, so the cosecant's going to be at 2. But now I'm going to multiply that by 2, so it brings it up to 4 at those two values. So now it's not only is it higher, it's steeper. Because multiplying by that makes it steeper. Because it grows faster. And then we do the -1, right? Doing the -1, I'm going to subtract 2 minus 1, so it brings it back down to here. And this one goes down further, down to here. So on the low end, the highest it gets is -3, and on the higher end, the y values start at +1. So now my range is from -infinity up to a -3, but it can include the -3. And on the high end, it starts at 1 and goes to +infinity. And my x values remain the same. It's all real numbers except for k pi over 2, where k is an integer. So let's look at them talking about it. So they started out with the sine function and the cosecant function together. And then once they start doing the transformations, they forget the sine function. They throw it away. So the first thing we do, we're going to multiply each of these y values by 2. And notice that the graph here got steeper. Not only did it get moved up, it got steeper or narrower, or however you want to look at it. And on the when it was below 0, it went down by multiplying by 2. So it went more negative, and again, it got steeper here. And then there was the excuse me, the vertical shift, which was moving everything down 2 units. 1 unit. And so it's the exact same shape, except everything got shifted down 1 unit. Okay. The domain remained the same. It's, oh, I said pi over 2 times integer. It's all multiples of pi. Is what x cannot be. So that's what they're saying there. And then yeah, and that's what I said here with this one for the range. Okay. Now, for some bizarre reason, I put in section 6.5 twice into this PowerPoint. So I'm just going to, rather than covering this section we just covered, I'm going to bounce through these slides again. I thought I had deleted these out of it, but obviously not. So here we talk, and we're going to be able to finish this section. So we're going to talk about phase shift and curve fitting. So we're gonna look at how we're given data points. How do I model those data points? So we're gonna do something so we can fit the sine function to fit the graph. So we'll have a sine function that will model the data. Whenever you create a mathematical model that explains the data, it does not mean that each data point is on the curve. It means the curve approximates the data. So it's a good predictor. Okay. So now we get introduced a new symbol. And that new symbol is phi. Right. Phi looks like the not symbol or the empty set symbol, but it isn't. It's a Greek letter phi, P-H-I, phi. And we use phi to find the phase shift. Right. So we have omega, and the capital omega looks like this. And if you know anything about electronics or you've delved into it, you see these symbols, and this is omega, and it talks about the ohms. And with electricity, you have a sine curve for the sound or the electronics, and then you shift it left or right, then that's the phase shift. So when we talk about a phase shift, we're talking about a horizontal shift. And phi helps us find those things. So now the phase shift, we use both phi and omega. So the phase shift is phi being divided by omega. I try and write omegas the same way every time. I'm not very successful at that, but I try and write it as a kind of a fat W with a loop in the middle, rather than coming up to a point. I create a loop in the middle. And the amplitude is the absolute value of a, the coefficient of the function, and the omega is the coefficient of x. Please notice they state that omega is positive. So if you have a negative x, you want to take that negative out appropriately. If it's sine, then it's going to change the sign of out here. And if it's cosine, you can just ignore it. But you have to be careful. Okay. If you're going to do that, then you need to factor omega out inside those parentheses, and then you can ignore the sign. But after you factored out a negative number. So like if you had 2x minus pi, then, or negative 2x minus pi, I'd factor out a negative 2. So it'll be negative 2 times x plus pi over 2. Because I would divide both of these by negative 2, and minus a negative is plus. And so if this was cosine, then it would just be the cosine of x plus pi over 2. If it was sine, sine of negative 2 times x plus pi over 2, then it's going to be the negative of the sine of x plus, oh, I gotta leave the 2 in there. Sorry. I'm just pulling the negative sign out, not the whole number. It's going to be 2 times x plus pi over 2. And this will be the sine of 2 times x plus pi over 2. Where I changed the sign. I changed the sign of sine. Okay. So the arguments remain the same. It's just it's gonna be the negative of the sign, and the other one's gonna stay cosine. It doesn't change the sign. It's negativity. Now the phase shift, since it's a horizontal shift, we have a shift to the left or a shift to the right. We have a shift to the left if omega is negative. We have a shift to left. That means this becomes a plus in here if omega is negative. And if omega is positive, that means this sign here will stay negative. Then we have a shift to the right if omega is positive. Okay. Now, for this problem, okay, it's gonna be difficult. Oh, I know the problem. I ran out of pages. So I'm gonna have to do it this way. Okay. So the amplitude is what the sine, or A is what the sine function is being multiplied by, and the amplitude is the absolute value of that number. And we go through and we find omega and we find phi. Omega is what x is being multiplied by. Phi is what you're adding or subtracting. And then the period, since it's sine, is going to be 2 pi over omega, which is 2 pi over 2, which is pi. And my phase shift is going to be phi over omega, which is pi halves, pi over 2. Is that all they were wanting to find? Are they asking us to graph this? Oh, yeah, and graphing it. So here's the phase shift. And here's the period. Since it's sine, my primary, my key 5 points are from 0, 0, pi over 2, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. All right, there's a couple of ways of looking at this. I can either change, I'm going to end up changing my x values by doing 1 over omega times those x values, which is 1/2. Or I look at what happens for that interval from 0 to pi. I end up dividing it into 4 pieces. So here I have pi over 2 and then pi over 4 there. And then that's going to be 3 pi over 4 here. And so finding those values there, I replace these x values with the new x values. So 0 stays 0. And the 1/2 became pi over 4. And the pi became pi over 2. And the y values haven't changed yet. 3 pi over 4, 3 pi over 2 became 3 pi over 4. And still paired with negative 1. And then the 2 pi became pi. Because when I multiply 0 by 2, I get that. And I multiply pi over 4 by 2, I get pi halves. I multiply pi halves by 2, I get pi. So that's how that all works. Now, the phase shift, because now what happened here is this function now looks, the graph of it looks like this now. All right. So that's what it's going to look like. And that was the compression. You can't see me squeezing my fingers together. That's the compression here. I'm pulling these values towards the y-axis. I pulled these values here towards the y-axis. So it increased the frequency. Now the phase shift, I'm shifting it half a pi. So I'm shifting it to the right a half pi. So instead of going through 0, 0, it goes through pi halves 0. Right? Because I added half a pi at this end, and so that's going to be pi over 2. I'm going to add half a pi at this end, so that's going to be 3 pi over 2. Half of 3 pi over 2 is 3 pi over 4, so this is going to be yeah, this is going to be, is that right? No, this is going to be 3 pi over 4, and I added another pi over 4, so that's going to give me pi, and this will give me 5 pi over 4. Yeah, that's right. Okay. So I'm shifting it a quarter, a half a pi in this direction. So this got moved, this point got moved up to here, and this point got moved up to here. So this is 3 pi over 4, and this one got moved up to here at pi, and then this one got moved over to here. So this one got moved to here, and so that's 5 pi over 4. So this is 3 pi over 4, 1, and this was what? Pi over 0, and then I got lost. I shifted this one over to here and this one over to here. Wait a second. I shifted this one up to here, this one up to there, and this one gets moved up to 3 pi. Yeah, 3 pi over 2. Yeah, okay. Yeah, I was just looking at the first period. I was, that's why I was confusing myself. And so it's going to start here and go up to here, and then come down to here, and then come back up to here. So this is the fundamental period here. is so this is the one we're looking at. This was 5 pi over 4. And this one was 3 pi over 2. All right. So that took care of everything in here. Now, once we're done in here, we need to multiply by 3. We multiply the y values by 3. So that's going to remain pi over 2, 0. And then the 3 pi over 4 now goes to 3 instead of 1. So this point got bumped up to here, where this one remained here. All right, this one remained here, where this one got moved up to here. And then pi 0 remained at pi 0. And 5 pi over 4 now goes down to 3. So this point got moved down to here. And 3 pi over 2 stayed at 0. So it came back up to here. So now it's going to go like this. Oops. And then I continue out a couple more. So it's going to go up to here and back down to here. And then down to here. Whoops, not far enough. And then down to here. And then back up to here. And so to continue it on, it went up to here, back down to here, back up again, and I'll stop there. And then going the other way, so it goes down to -3 and then back up to back up to 0, and then up to 3, and then back down to 0, and then back down to -3. And so that's how it goes over here. Wait a minute. This one's going to be here. No, I did those wrong. I got off a little bit. It's going to go through here and then up to here and then down to here. Okay. Sorry about that. And so there we have it. And then we go through theirs. And they look at it a little differently than I do. What they did here, they factored the 2 out of 2x and minus pi. So dividing each one of these by 2, that gave us x minus pi over 2 in here and omega out here. So omega's out here, and then phi over omega is right here, 1/2, which is what we got for the phase shift was pi halves. Okay. So the amplitude is 3, the period was pi, and the phase shift is pi over 2. And they go through and they look at what's happening. They look at the interval. They look at the 5 key points as far in terms of the period. And so the period was from 0 to 2 pi. But now it's from 0 to what? To pi. And we add to each of these, we're going to add pi over 2. Oh, we're past time now, aren't we? So I'll continue with this next time, and we're at slide 186. Okay, so unless you have questions for me, you're free to go. Please come back in one piece for next week. You have not
Thank you.
signed in to chat already, please do so.
Thank you. Have a good weekend.
You too, take care,
Have a good one,
Have a good
Professor.
weekend.
enjoy. Stay well, double mask when possible. All right, Brian, Christopher, you got questions for me? Okay, I'm gonna go ahead and close the session now. We'll see you next week. Don't forget to email if you have any questions.